Again, my name is Rukami Escasabana from ECE31 of DLSUD Electronics Engineering, and welcome back to my YouTube channel. So for our episode today, we will be discussing our summative assessment number 1 in Digital Electronics 2, which will enable us to explore a digital input and output application using Pickit3 and our integrated circuits or microcontroller. So in my part, I decided to create an idea or have an alternative for our LED or light display of a simple pedestrian lane, which can be used to improve the safety in terms of our traffic management as well as the safety of our pedestrians. So this is submitted to Engineer Emmanuel Longares, which is our instructor and professor for Digital Electronics 2. So moreover, for the objectives of our project or our summative assessment, we aim to create a flowchart that depicts the logic of the program code on Mplab software. Second, we aim to create an Mplab source code that can be used for the application of the digital input and output and be able to build it in our breadboard. And lastly, we aim to use the Pickit3 with the Mplab and electronic components to test the code and perform the application of the digital input and output in the actual circuit on our breadboard. So for our equipments and components, we will be needing our microcontroller, which is the PIC18875. Next one will be our 220 ohms resistor minimum, and you can actually use 220 to 1000 kilo ohm, but not a huge amount, so that our LED will light up. Then we will be using LEDs. Any color of your choice will be good. Then typically our breadboard, our connecting wires, our Pickit3, and our power supply or batteries. So as you can see on the picture, this is the logic where I based my idea for the summative assessment. So by programming or using our microcontroller to manipulate or control the behavior or the function of our LEDs, improvise or have an idea to innovate an existing system, let's say for example our traffic lights or our pedestrian lanes, to be able to make our places more and convenient. Like in this idea of mine, I will be using lights to be indicator, which will give the pedestrian time indications, plus the color of the LED indications, which will allow the pedestrian to know if it is safe to cross the street already, especially on those areas which are really high-speeding vehicles because it's a highway. So as you can see here, we can have a digital input through a switch or let's say a lever, which the pedestrian can pull or can press if he wants to cross the lane. And we can also apply it in pedestrian lanes like this on China, which they use lights to serve or to aid those people who cannot see on the dark clearly, or to serve as light as well for pedestrians, especially in midnight. And of course, this one, which will be our foundation using our breadboards on our Onyx foundation. So for our flowchart, let me explain it to you. So first one will be our start. Then we need to initialize our switch 1 and switch 2 as our digital inputs, okay? And also, we need to initialize 6 LED as our digital outputs. And we need to treat, for our process, okay, we need to treat LED as outputs. So we will be naming the 6 LEDs in our Mplab IDE software later on, which will I show later on when we discuss about the programming part. And then we will be having a decision here, which will allow our code to decide whether to perform an action or process or not. So if switch 1 is pressed, if it's true, then the output should be the LED, which is the color red, which will I show later on, will be set high or will be turned on. And if it's false, it will go back to the loop wherein it will ask if the switch 1 is pressed. Then if it's true and the condition is satisfied, see here that we will be performing while. So while our switch 1, or let's say while our switch 1 is pressed and the red LED light is already turned on and approaching to be turned off, then another question will be imposed by the program. It will ask if switch 2 is pressed, or let's say switch 2 sense a motion because we will be using a tactile switch later on, which is on our touches. Tactile switch number 2 is pressed. It will process or it will output the lights, or the 6 LEDs will turn on. So meaning they will turn on but with a specific time delay and time interval of 250 milliseconds per LED. So this allows us by not letting all of our LEDs turn on at the same time. So that's the essence of this toggle option for our LEDs. Then after that, after performing all of those actions from our code, then it will be the end of our program. And it will just look and happen again as long as it serves its purpose as a pedestrian lane indicator. So for our source code, we will be proceeding to our Mplab IDE software.
Now we will make our own project, which is a standalone project. And now we will be choosing our IC or our microcontroller as PIC16F18875. And then we will be clicking next and selecting the compiler for our project. Then we will be renaming our project Casabuena RM. It's up to you, depending on your name. And then let's browse our location. So let's put it on the right folder so our files will be organized. And then let's click next, and then let's just wait for the software to load up. And now we will go to our project, and then we will close the unnecessary tabs here. So we will go to the file, and then we will be editing the code configurator on Mplab XIDE. We just have to save this one. Okay, and in this part we will be editing our parameters.
So now, explaining all of our systems which we use in our Mplab XIDE. So in our system module, we set our oscillator select to HF INTOSC, and we set HF internal clock to 4 MHz, and then clock divider to 4, and then turn on the low voltage programming enable. And then we will go to pin module, and then after that, okay, as you can see here, we consider 6 outputs for our LEDs from RE1 to RE0. So as you can see here, okay, so this first 5 is considered as output. So here's the other one, the RE here, and then our output will be the pin number 37 and 36 of our IC. So as you can see here, it's on RB4 and RB3. So it's our digital input for our switch. And for the settings, we renamed all of our LEDs, okay, including their position, or let's say pin on the IC. And then we also renamed switch number 1 and switch number 2. And then we untick analog, and then we considered output for the 6 LEDs, and then WPU for the 2 switches. And with this, we will generate our code. Okay, so let's just wait for it to load up for generation, and then after that, there should be a pop-up here saying generation complete, and then we will go to our projects, then we will go to our main C file. So let me explain to you the logic behind the code. So here we will be considering the function while, and then the function or the command if switch 1, which is connected to our IC, get value is equals to 0, it means that our LED1, which is our red LED, will be turned on or set high. Else, if the switch is not pressed, then the red LED or the LED1 will be turned off or set low. And then we have another condition wherein if the switch number 2 is switched, or let's say it sensed from your fingertips, and then we will be displaying blinking of our LED lights with a time interval of 250 milliseconds. So we use the command delay to have a time interval difference for each of the 6 LEDs that we will be using to indicate that the pedestrian is safe to cross the lane already. So we considered a 250 milliseconds time interval. But if you will be applying it in true life, you can just use these figures to to just simulate the LEDs using our breadboard. But in real life, you can actually use seconds to consider as the true time interval for an actual pedestrian lane, because milliseconds is too fast. So you have to take note of that. But for the sake of simulation and for the sake of our breadboard simulation circuit, we will be using milliseconds. So we set the toggle command for all of the 6 LEDs, wherein after the red LED turned on, then the next LED will turn on as well, then the rest will follow with the 250 milliseconds time interval. And after that, that will be the indication that the pedestrian will already be allowed to cross the lane. And the time duration will be the time delay wherein the pedestrian will be given ample time to cross the lane. So in this part, the LEDs will be turning on. Okay, the LEDs will be turning on with a time interval. But in this part, we use a command else. In this part, if the LEDs is not turned on, then it will be set low. Meaning, after turning on with an interval of 250 milliseconds for each of the LED will also turn off if it's not turned on. And then after that, the cycle will repeat. So again, if the switch 1 is on or pressed, then the red LED or the LED 1 will turn on. And then after that, the rest of the LED will follow with a 250 milliseconds interval. And then this will be the ample time given to the pedestrian or to the person crossing the lane to cross the lane. And then there will be a blue LED on the end, which will be our LED 6, which will be the indicator that the person already consumed the 50% of the time for him or her to cross the lane. So that's our indicator. And then after that, the LEDs will turn off as an indicator that time is running out. And then the red LED will turn on again to indicate that the person or the pedestrian is already not allowed to cross the lane. So that's the logic of our traffic lights for our pedestrian lanes. Now, with this code, we will build it so that we will be able to connect it to our Pickit3 later on. So let's just wait for it, and let's just wait for the programming, or let's say the build successful motif here. So as you can see, this one here. So now we will be constructing our circuit. So this is our breadboard. So again, the IC is already connected to the VDD and to the VSS, which is VSS should be connected to the ground, and then VDD to the positive voltage supply. And then we will be needing our LEDs, okay, 6 LEDs. So for our first connection, we will be connecting RA1 to RA5 of our IC to our LED. So let's have some connection. So RA1 is on pin number 3 of the IC. So 1, 2, 3. So this is RE1, okay, this is RE1, then let's put it here, and then RE2 will be next. So RE2, then we will be considering RE3 as well. So RE3 here, so RE3 here, and RE4 as well. So let's use another colored wire here, RE4, which is on pin number 6. Then we will be also considering RE5 here. So last one, we will be using RE0. So RE0, so let's use another colored wire here. So RE0 on pin number 8 of our IC. So RE0. So now let's connect our LEDs. So the first LED will be the red LED. So positive to negative, and then the green. So let's connect ground to our LED so it will light up. So let's put our ground here. Then next colored will be green. So let's connect it here, and then let's ground it as well. Let's ground it. And then we will also be connecting green resistor from pin number 4 to pin number 7 of our IC. So resistor, then ground, and then resistor, and then ground, and then another LED here, and then ground. And then last one will be our blue LED, which will be our indicator. So blue LED here, then another one on the ground. So that will be our connection for our LEDs. So that's our connection for our LEDs. And the next one will be for our switch. So we will be using a tactile switch for our circuit. So 2 tactile switch, which will be our digital input. So if it's pressed, or let's say it sensed some vibration on it, then it will turn on our LED. So let's put it here on the middle of our breadboard. So this is for 1, and this is for switch number 2. So switch number 2, then let's put it here. And then as you can see and you can hear, that's the sound of our tactile switch. So next one, so our switch number 1 will be on RP4 or pin 37 of our IC. So 40, 39, 38, 37. So this will be our switch number 1, 37. So connected to our switch number 1 here, and then our switch number 2 will be on pin number 36, so connected here on our tactile switch. Then let's ground both of our tactile switch here. So let's ground it, and let's ground the other one. So we will be connecting our Pickit3 programmer already. Okay, so we will be connecting it here, and then we will program our IC using our Mplab. So we will be connecting our Pickit3 to our circuit already. So that's our circuit for our summative assessment number 1, consisting of 6 LEDs with 1 red, with 4 greens, and with 1 blue LED. We will be going to the Mplab X IPE here. So now we will be connecting our Pickit3 to our Mplab X IPE to put our source code or to program our microcontroller. So let's just wait for it to load up. So there will be a pop-up here saying that we need to edit our settings. So let's go to our advanced mode, and then the password will be microchip. Press enter, and then let's change our voltage level here to 3.125 so that our IC will not be destroyed. And then let's go to operate, and then we will be uploading our hex file here, which is our source code for our summative assessment. And then let's go to program, so it will process our source code so that it will be acknowledged or recognized by our Pickit3. So as you can see here, there will be an pop-up here saying programming complete. So that's the indicator that our code is successfully installed or recognized by our Pickit3. Now, this will be our circuit for our summative assessment number 1, wherein we used 6 LEDs for our circuit implementation, wherein our first LED, which is, I hope you can see, the first LED will be the red one here. So this is the first LED, and then the 4 LEDs after the red LED are 4 green LEDs here, and after that we used a blue LED here. So what is the essence of the different colors of LEDs in our simulation? So the first color is the red LED, which will be our indicator for every transition, and our indicator wherein the person will be allowed to cross the pedestrian lane and will not be allowed to cross the pedestrian lane. And after that, the 4 LEDs here, or the 4 green LEDs, will be the indicator of the time wherein the person will be allowed to cross the pedestrian lane. So it's the given time for the person to cross. Then the blue LED here will be another indicator that the time is almost up for the person to cross the pedestrian lane. So in that way, using our indicator lights in this experiment, we will be improving the safety in our pedestrians. So we will be demonstrating now our simulation. So once I pushed this button here, there's 2 switches here, our LEDs will start to turn on. So let me first push this one. Okay, so as you can see here, the LEDs are turning on and off with a 215 milliseconds interval. So this time, the LEDs are turning off. So the red LED here will turn on once as an indicator, and then the blue LED here at the end. So this is a nice practical application for our pedestrians, wherein the red LED will be our indicator, which will allow the pedestrians to know if it is already safe or not safe to cross the lane. And our 4 green LEDs here will be our time duration. Okay, the persons are given 2 signals that will let them know if it is safe or not safe to cross the lane. So the first red blink here will be the signal that it is now safe to cross the lane, and the second blink of the red LED will be an indicator that you are consuming half of the time already of your crossing. And the blue LED here will signal that time is almost over to cross the lane. So probably you won't want to cross the lane because time is already up. And the green LEDs here, the 4 LEDs here, are your time duration given for you to cross the road. So with our red and blue LEDs, we will be able to know if you are allowed or not allowed to cross the lane. So that's the logic behind our summative assessment number 1 for our traffic lights for our simple pedestrian lane. You can actually manipulate or change the time duration to actual seconds for practical and actual application in real life in our pedestrian lanes. So that's our summative assessment number 1. So I hope you learned something, and I hope you will be enjoying controlling or manipulating with your codes and with your circuits. Thank you.